So we talked previously about scientific notation and multiplying and dividing by powers of 10. What we're now going to talk about are units of measurement and unit conversions. So units provide meaning to numbers by indicating what you are measuring and what standard unit of measurement you are using. So for example, 10 meters. 10 is just a number. It doesn't have any inherent meaning in our physical world until we apply a unit. Now, because we're looking at 10 meters, we know that we're describing a unit of length. Now, the US commonly uses the English system of measurement, but the sciences typically use the metric system. And when we think about the importance of units, it's really important to understand the relationship between different units, even in different systems, such as the English and metric system, because if you incorrectly handle units, or if you incorrectly measure out the wrong amount of material, it can have significant consequences when running an experiment. So one example that I found that was quite interesting is that when a toddler was brought in to treat an eye infection, and they were going about developing and figuring out the proper dosage of a medication, the discharge paperwork listed a weight of the infant as 25 kilograms rather than their true weight of 25 pounds, which is about 11 kilograms. Because an incorrect unit was entered, and because this unit error wasn't corrected, an incorrect dosage of medication was given. So this is a very common example where paying attention to units and understanding the relationship with units can help avoid quite significant accidents. So when we start to talk about units, let's talk about the relationship between different unit systems, and let's talk about the rules and processes to convert from one unit of measurement to another. So the metric system is based on powers of 10, and this makes scientific notation especially useful when handling numbers in the metric system. Now, one hallmark of the metric system is that it's built on what are known as base units. Distance is described using units of meters, volume, liters, mass, grams, time, seconds, and temperature, kelvins, or in some cases, degrees Celsius, though Kelvin is massively preferred for temperatures. Now, one really wonderful thing about the metric system is to indicate large or small quantities of a unit. The metric system uses a set of common prefixes, each with a unique symbol. This prefix modifies our base unit to give what's known as a prefix unit. So for example, a centimeter describes 10 to the negative second meters. In this case, as we can see, the prefix directly corresponds to a power of 10 quantity of our base unit. A kilogram is 1,000 grams. A milliliter is 10 to the negative third liters. Each prefix corresponds to a power of 10 quantity of our base unit. Now, these are the metric prefixes that you'll need to be familiar with. You're responsible for memorizing each of these prefix symbols, names, and power of 10 values, because each of these prefixes are used commonly in chemistry and chemical calculations. Now, the reason why it's important to be familiar with each power of 10 value for each of these prefixes is because it gives you a very easy trick to convert a prefix unit into a base unit. So to convert a prefix unit to a base unit, all you have to do is replace the prefix with its corresponding power of 10. So for example, 657 millimeter, I'm going to find my prefix, in this case, milli, and we see the milli prefix corresponds to 10 to the negative third. So I'm just going to replace my milli prefix with 10 to the negative third. And so we see 657 millimeters corresponds to 657 times 10 to the negative third meter. And we know how to do multiplication operations with powers of 10. So 657 times 10 to the negative third, we move our decimal point 1, 2, 3 spaces to the left, and that gives us 0.657 meters. Don't forget your units in your final answer. Let's do another example. If we have 457 kilograms and we want to convert that into grams, we can easily go from this prefix unit to the base unit by replacing our prefix with the corresponding power of 10. Kilo corresponds to 10 to the third. So we know 457 kilograms are equal to 457 times 10 to the third grams. And again, we know how to multiply by positive powers of 10. We put our decimal point at the end and then move our decimal point, in this case, 3 spaces to the right. That in turn gives us 457,000 grams. Don't forget your units. They're critically important. So we've talked about each of the common metric prefixes, their base 10 value, and we've shown how we can convert from a prefix unit to a metric base unit by replacing the prefix with its corresponding power of 10. Now, this is a shortcut. What we're going to talk about next are more thorough ways of converting between units in the metric system and eventually performing English to metric conversions. So, to help us understand unit conversions, it's important for us to think a little bit about what a number and a unit is trying to represent. So different units and numbers can describe the same quantity. So for example, centimeters and inches both describe distance. And if we wanted, we can use 2 different units to describe the same quantity of distance. So for example, if we measured out 1 inch, so this is 1.0 inches, and we decided to measure the exact same length or the exact same quantity of distance in centimeters, we see that that turns out to be about 2.54 centimeters. So 2.54 centimeters is the same amount of distance as 1 inch. These 2 values, these 2 quantities are equal, right? The red line is at the same spot in both of these rulers. So a unit conversion is best described as a ratio of 2 equal quantities. We know 2.54 centimeters in length as 1 inch. So we can write out a unit conversion ratio as a ratio of these two quantities. So we know that if we, for example, divide both sides by 2.54 centimeters, we get a ratio of 1 is equal to 1 inch over 2.54 centimeters. We can also write the inverse ratio, where we have 1 is equal to 2.54 centimeters over 1 inch. These two ratios are our unit conversion factors. And we can use these unit conversion factors to convert between two units of measurement. Okay, so we've established two different numbers and units can be used to describe the same quantity, right? 2.54 centimeters are equal to 1 inch. We can create a unit conversion ratio by taking a ratio of two equal quantities. So we have 1 inch over 2.54 centimeters, or 2.54 centimeters per every 1 inch. Now, to bring us back to this idea from algebra, you can multiply any quantity by 1 and the quantity is unchanged. The units and the number change when you convert between different units, but the actual quantity does not. Likewise, when multiplying and dividing by unit conversion factors, the units cancel just like normal numbers. So for example, if you have 7 times 2 over 7, your two equal quantities on top and bottom will cancel out. Likewise, when you're converting from 2 centimeters to inches, we can multiply by this unit conversion factor, which is 1. Inches cancel, and we now have a new number and a new unit to describe the same quantity of distance. Inches over inches, same values cancel. We multiply out our number and we are given a new number and unit. So if we were to make just like an overlay, so if this distance is 5.08 centimeters, and if you put an inch ruler right next to it, 2 inches is describing the same amount of distance, the same quantity. We just have a different number and a different unit. What's really important in unit conversions is that you really have to make sure the units cancel. So in this case, inches over inches, inches cancel. And you need to make sure that you write out all the units associated with a number. Students commonly have trouble with cubic or square units in that they need to write out all of the units and completely convert all of the units in order to complete the unit conversion problem. So this is an overview on why unit conversion works. Let's talk about a practical guide for how to convert from one unit of measurement to another. So we'll do this in the context of a problem. How many milligrams are in 3.46 times 10 to the first kilograms? So 3.46 times 10 to the first kilogram, and we're trying to figure out that's equal to how many milligrams. Okay. Our first step is to indicate what units you're starting from. So let's look at our given number here, and we see that we're starting from kilograms. Okay, this is the start of our unit conversion map. We're then going to indicate what units we are trying to convert to. So we want to go from kilograms, and the problem is asking for milligrams. So we're trying to go from kilograms to milligrams. Now, it's generally tricky to go from prefix unit to prefix unit. So instead, what we're going to do is we're going to go through the base unit. And in this case, the base unit for both kilograms and milligrams are the units of grams. This is our base unit. And the reason why we go through the base unit is, as we've seen when we looked at different metric units, it's very easy to convert between a prefix unit and a base unit in the metric system. Okay, so now that we have our unit conversion map, we're going to talk about each step of this unit conversion map. So we want to go from kilograms to grams to milligrams. So let's talk about this first step. If I want to go from kilograms to grams, we need to identify a conversion factor containing the desired base unit and the starting prefix unit. Okay, so we know that 1 kilogram from our table, 1 kilogram, kilo corresponds to 10 to the third gram. Okay, so we have our equality now, and we can use this equality to make two conversion factors. So we have 1 kilogram over 10 to the third gram. That's one option. And we have 10 to the third gram per 1 kilogram. Okay, so when we want to go from kilogram to gram, if we want to convert from our prefix unit to a base unit, we want to make sure our units cancel. So let's bring our number into this. So we have 3.46 times 10 to the first kilogram. And we want to go from kilogram to gram. So if we want grams to end up in our final answer, and we think about our unit conversion factor, in order for grams to end up on top in our final answer, our unit conversion factor will need to have grams on top. Likewise, if we want kilograms to cancel, we need kilograms on the bottom. Generally, when I draw my unit conversion map, I like to draw a purple arrow, and I put the unit that I want on top and the unit that I'm going from that I want to cancel on the bottom. So grams will be on top and kilograms will be on the bottom of our unit conversion factor. Make sure that you always keep the power of 10 with the base unit, and now all we have to do is fill in the blank. We know that there are 10 to the third gram per every 1 kilogram. Kilograms cancel, and what we're left with is 3.46 times 10 to the first times 10 to the third gram. Now, when you're dealing with multiple powers of 10 and multiplying powers of 10, if you're multiplying powers of 10, you can simply add the two exponents together. So we have at the end of our first conversion step, 3.46 times 10 to the fourth gram. If you're uncomfortable with this step, you can multiply everything out and then just rewrite the number into scientific notation. Okay, so let's make sure that we're still on the same page here. We went from kilograms to grams, and we want to get to milligrams. So we've identified our base unit, we've reached our base unit, and we've converted to our base unit using our unit conversion factor. Now let's think about the second step for our unit conversion map. So we have 3.46 times 10 to the 4th grams. We went from kilograms to grams, and now we want to go to milligrams. So again, I'm going to make an arrow, and in my conversion factor, I want milligrams on top and grams on the bottom. Okay, so let's find just some equality that contains my base unit and my desired prefix unit. So I want something to relate milligrams and grams. And we know from our unit conversion table, if we go all the way up to a common unit conversion table, we see that the milli prefix corresponds to 10 to the negative third. So then we know 1 milligram corresponds to 10 to the negative third gram. We can inherently relate a prefix unit to the base unit by just replacing the prefix with the corresponding power of 10. Okay, we now have our equality, and we can get two different unit conversion factors. We know that there are 10 to the negative third gram per milligram, or we know that there's 1 milligram per 10 to the negative third gram. Now, of these options, when we think about completing this unit conversion, we want to go from grams to milligrams. We've established that we want milligrams on top and grams on the bottom of our unit conversion factor. So that way, we can cancel out our undesired units of grams, and we're left with our desired units of milligrams. So then, if we want to end up with milligrams at the end and milligrams on top, we're going to use our conversion factor that places milligrams on top and grams on the bottom. Remember, the power of 10 always stays with the base unit. As we see, grams cancel and we're left with milligrams. So we have 3.46 times 10 to the 4th times 1 over 10 to the negative third milligrams. And again, there are two ways you can go about this. I find the easiest way is just to rewrite this division operation as a multiplication operation. Dividing by a power of 10 is the same as multiplying by the negative power of 10, and negative 3 times negative 1 is positive 3. So then we can just add our exponents together. So 3.46 times 10 to the 4th times 10 to the 3rd milligrams turns into 3.46 times 10 to the 7th milligrams. Just to show you this full operation in one line, we wanted to go from kilograms to grams to milligrams. We started with 3.46 times 10 to the 1st kilograms. And our first step was to go from kilograms to grams. So we want a unit conversion factor that has grams on top and kilograms on bottom. We know 1 kilogram corresponds to 10 to the 3rd grams. Kilograms cancel, and we're ready for the next step. To go from grams to milligrams, we want milligrams on top and grams on the bottom because we need to cancel grams. Grams cancel, and we know 1 milligram corresponds to 10 to the negative third gram. Multiplying this all out, we end up with 3.46 times 10 to the 7th milligrams. So now that we've seen an example of metric to metric conversions, let's do a follow-up example, this time looking at units of length. So in this case, we're asked how many nanometers are in 4.5 times 10 to the 4th picometers. So we have 4.5 times 10 to the 4th picometers. So my first step is to identify my starting units. So I'm given starting units of picometers. And what are my desired ending units? In this case, they are nanometers. Now, we have two prefix units. So rather than going directly from prefix to prefix, instead we're going to go through a base unit. And the shared base unit for picometers and nanometers is going to be the base unit of meters. Perfect. Okay, so let's just look at the first step now. So I'm trying to go from picometers to meters. So we have 4.5 times 10 to the 4th picometers, and we're trying to convert this to meters. I'm going to draw my arrow. I want meters on top and picometers on the bottom of my unit conversion factor. And I know 1 picometer corresponds to 10 to the negative 12th meter. Let me just check that. And just to show you where to check that, if we go all the way up to the metric prefix table, I found the pico prefix corresponds to 10 to the negative 12th. So then we know from that a picometer corresponds to 10 to the negative 12th meter. We just replace the prefix with its power of 10. That gives us two possible conversion factors we can use. 1 picometer per 10 to the negative 12th meter, or 10 to the negative 12th meter per 1 picometer. So looking at our unit conversion map, if we wanted to go from picometer to meter, we'd want meters on top. So we'd have 4.5 times 10 to the 4th picometer. And then in our unit conversion factor, we choose the conversion factor with meters on top. So we'd have 10 to the negative 12th meter per picometer. Picometers are also on the bottom, so the units cancel. And that in turn gives us 4.5 times 10 to the 4th times 10 to the negative 12th meter, which gives us 4.5 times 10 to the negative 8th meter. So we checked off our first box here. Now we want to go from meter to nanometer. So if we have 4.5 times 10 to the negative 8th meter, and we want to go to nanometer, nanometer is going to be on top, meters are going to be on bottom. And we know, just to make another table, we know that 1 nanometer corresponds to 10 to the negative 9th meter. So again, we can make another set of conversion factors. So we have 1 nanometer per every 10 to the negative 9th meter, or we have 10 to the negative 9th meter per 1 nanometer. Since we want nanometers on top, we're going to multiply by the conversion factor with nanometers on top. So in this case, we have 1 nanometer over 10 to the negative 9th meter, which gives us 4.5 times 10 to the negative 8th meter. Meters cancel. We're left with nanometers. So we have 4.5 times 10 to the negative 8th over 1 over 10 to the negative 9th nanometer, which simplifies to 4.5 times 10 to the negative 8 times 10 to the 9th nanometer, which simplifies to 4.5 times 10 to the 1st nanometer. Now, if you wanted to do this in one line, let's show the one line solution. So we're wanting to go from picometer to meter to nanometer. To go from picometer to meter, we want meters on top. So we have 10 to the negative 12th meter per 1 picometer. Picometers cancel. To go from meters to nanometers, we want nanometers on top. And we know 1 nanometer corresponds to 10 to the negative 9th meter. Meters cancel. And in this case, we're left with 4.5 times 10 to the 4th times 10 to the negative 12th times 10 to the 9th nanometers, which in turn gives us 4.5 times 10 to the 1st nanometers. So as you can see, either the one-line method or the stepwise method work. And I want to encourage you, as you get more confident with these problems, to start attempting to solve these unit conversions with the one-line method. Now, I know these problems, we need a lot of practice, so I'm going to do another example for you. So this time we're asked how many centimeters are in 0.5 times 10 to the negative 3rd millimeters. So we're starting off with 0.5 times 10 to the negative 3rd millimeters. So we're starting off with units of millimeters, and we are trying to get to units of centimeters. So with that, what is our shared base unit? Millimeters, centimeters, our base unit is meters. Okay, so to break this down now, we're going to look at each step individually. So first, we're going from millimeters to meters. So we're going to want meters on top. So we know 1 millimeter corresponds to 10 to the negative 3rd meter. So when we're designing our unit conversion factor, if we want to go from millimeters to meters, we're going to put the units of meters on top of our conversion factor. So we have 10 to the negative 3rd meter per millimeter. That gives us 0.5 times 10 to the negative 6th meter. Now to go from meter to centimeter, we're going to want centimeters on top and meters on the bottom. We know 1 centimeter, the centi prefix, corresponds to 10 to the negative 2nd meter. We're just replacing the prefix with the power of 10. Now, because we're going from meter to centimeter, and because we want the units of centimeter on top, we're going to take our base, which is 0.5 times 10 to the negative 6th meter, and we're going to multiply by our conversion factor that places centimeters on top. So we're going to put 1 centimeter on top and this 10 to the negative 2nd meter on the bottom. Meters cancel, and we have 0.5 times 10 to the negative 6th times 1 over 10 to the negative 2nd centimeter, which simplifies to 0.5 times 10 to the negative 6 times 10 to the negative second centimeter, which we can simplify to 0.5 times 10 to the negative fourth centimeter. That is commonly written, just rewritten as 5 times 10 to the negative fifth centimeter. Now, to show this conversion in the long form method, let's just show a one-line conversion. So we're trying to go from millimeter to meter to centimeter. To go from millimeter to meter, we put our units of meters on top. So we have 10 to the negative third meter per millimeter. Millimeters cancel. To go from meters to centimeters, we put units of centimeters on top. And we know in 1 centimeter, there are 10 to the negative second meters. Units of meters cancel. And that in turn gives us 0.5 times 10 to the negative third times 10 to the negative third times 10 to the second centimeter, which in turn gives us 0.5 times 10 to the negative fourth centimeter, which gives us 5 times 10 to the negative fifth centimeters. So both the one-line and stepwise method work for metric to metric conversions. So now what we're going to do is we're going to have you take a moment and work on the following unit conversion examples. There are a total of 2 of them for this problem-solving session, and then I'd like you to submit your responses in the corresponding Canvas module. And we'll discuss both of these problems after you've completed and submitted your responses for each of these 2 questions.